Over this and the next few videos, we're going to discuss this notebook where we implement feature engineering or feature transformations over the house prices dataset from Kaggle. If you haven't downloaded the dataset yet, you can find instructions on how to do so here and also in section 1 in the lecture called Download Dataset. Make sure you download both the train CSV and the test CSV and save them in the same folder that you have the notebooks. We're going to implement some steps that include some sort of randomness, so it is very important to remember to set a seed for reproducibility in each of those steps. So for this notebook, we're going to import pandas and numpy for data manipulation, matplotlib for plotting, scipy stats for the Eo-Johnson transformation. We're going to import from scikit-learn the train test split function to separate the dataset into a train and a test set. And we're going to import the min-max scaler from scikit-learn as well to perform the scaling of the datasets. This is because we aim to build a lasso regression as we progress with the pipeline, and the lasso requires that the features are within a similar scale. We're also going to import joblib to save the train min-max scaler. We load the datasets, we print in columns and variables. You are familiar with this already. And now we're going to separate the dataset into a train and a test set. And this is because when we engineer features, some of the techniques learn parameters from data. For example, when we learn the mean value to impute a variable, or the most frequent category to impute a categorical variable, or the exponent of the Eo-Johnson transformation, or the mappings of strings to numbers for the categorical variables. So all of this learning needs to occur on the train set so that we don't leak information onto the test set. We want the test set as naive as possible to any of the learning techniques to get a better representation of the real accuracy of our model. To separate the dataset into train and test, we use the train test split function from scikit-learn. We're going to drop the ID and the sale price in the predictor variables, which are captured in this line. The target is the sale price, and we're going to keep 10% of the observations in the test set, and here we set the random state for reproducibility. So when you and I run the notebook, we should obtain the similar split, but more importantly, we need to keep the split the same between the research and later on the production environment. We're going to perform the following steps of feature engineering. We're going to impute the missing values. We're going to capture the elapsed time in the temporal variables. So instead of using the temporal variables as such, we're going to capture the difference between the temporal variable and the year in which the house was sold, as we explored in the data exploration videos. We're going to transform variables to make them more Gaussian looking. We're going to remove rare labels, and then we're going to encode the strings of the categorical variables into numbers. And finally, we're going to set all the features within the same scale. We said that we would work with the logarithm transformation of the target to improve the value spread and make it more Gaussian looking. In the first part of the code, we will capture the categorical variables in a list, as we did here and in the previous notebook. So for each variable in the columns of the dataset, if it is of type object, we capture it in this list because it is categorical. And then we add subclass that by definition is categorical even though its values are numeric. We cast them all as object, so this one that is not object, we cast it as object. And now we capture the categorical variables that show missing data, which are the ones that we see here. I will impute these categorical variables in two ways. For the variables that present a lot of missing data, like these four here, I will replace the missing information with a string that is called missing. You can give it any name. I'm going to give the name missing. And the variables that present very little missing observations, I'm going to replace these values by the most frequent category. I'm going to do this as an arbitrary decision. We can, of course, do more data exploration and decide if maybe some other method works. But for the rest of this course, we're going to capture the variables that have more than 10% of the observations missing in a list, which I'm going to impute with the string missing, and the remaining variables with NA that are categorical, so those that have information missing in less than 10%, I'm going to capture it in this other list. To replace the labels with the string missing, I'm going to go ahead and use the pandas method fillNA, both in the train and the test set, and fill the missing values with the string missing. This is what I'm doing in these lines of code here. And to replace with the most frequent category, I need to first determine the most frequent category. So for each variable in this list of variables, the first thing I do is I determine the most frequent category on the variable in the train set. Here it's important that we learn from the train set. With mode, I determine the most frequent category, and with this we capture the first value. We print the variable and the mode we are going to need for later, and then we proceed to fill the missing values with the mode that we determine on the train set, both in train and test, with the method fillNA from pandas. Here we can see that it actually worked. Now we explore the variables that are numeric and show missing data. In this line of code we capture the numerical variables, and here we capture the numerical variables with an A, and here we can determine the percentage of missing values for each one of these three numerical variables. And we're going to impute these values in two ways. First, we're going to add a missing indicator, so an additional variable with the value 1 or 0, depending on whether the information was missing or not. And in the original variable, we replace the value that is missing by the mean of the variable. This is what we do in this bit of code. So for each one of these three variables with an A that are numerical, first we determine the mean with the pandas method mean. We print the variable and the mean value, which will be useful for later in the course. Now we add the binary indicator, so in the train set and also in the test set, we create a new variable with the original variable name plus underscore NA, and using numpy and beware. If the value in the variable is null, we place a 1, or otherwise we place a 0. And then we replace the missing data with the mean utilizing the fillNA method from pandas. We can corroborate that now we don't have missing values in these numerical variables anymore, and we can also explore the new added binary indicators as we do here. That is all for missing data imputation. In the next video, we're going to explore more feature engineering.